with like the 1 is bigger than 2.
Okay, class. We are going to go ahead and get started. Everybody should be on this page. It says April 12th, 2021. Comparing fractions. Everybody's got it? Good. Thumbs up. Good. So, let's take a look at what we have today. We've got this one, comparing fractions with like numerators. That means your top number is the same, right? But it means the bottom number is not. Now, quick question. Pop quiz. What does the denominator stand for? What does it do? What does it mean? Sellers.
How many parts there are?
How many parts there are in what?
Oh,
That's right. How many parts there are in the whole. Now, what is the numerator? What's the numerator? Heston.
Ian.
It's not the opposite, but you're on the right path here. What does it mean?
I'm done.
You're done with your math? Yeah. Okay, well, good to know. We're still going to go through it together, though. Jen.
How many parts are shaded?
How many parts are shaded or how many parts are represented? That's right. Sometimes it's how many parts you're taking away, right? That's right. How many parts are represented? So, keep that in mind when you're going through this one. And it says to compare, of course, with our greater than, less than, or equal than symbols. Next one is like denominators. My opinion, these are the easier ones. Because you're talking about something where the whole is cut into the same number of parts, right? That should be easier for you. And then, last one, fraction word problems. Fraction word problems. Pay attention to these guys. Read them carefully. Circle, underline, highlight the important information on these. You're going to see a lot of word problems as we move forward, okay? So, what we're going to do is we're going to spend just a little bit of time working on these individually in your groups. If somebody has a question, you can help them. But again, I want to reiterate this. Reiterate means I'm going to repeat it again, okay? You cannot give people the answers, but you can help each other. You can help each other understand it, but you cannot give people the answers, okay? So it can't be one person doing all the work and another one saying, okay, what was the answer to this one? No, can't do that, all right? But if somebody does say, hey, I don't understand this part, can you help me understand it? You can try to help your teammate understand it, okay? Now again, for those of you who do not have your packets, the Chloe's, you're going to have to catch up on this work. Let me see if I can print. Let me see if I can print a couple ones for you guys to work on right now, okay? In the meantime, go ahead and get started, everybody. We will come back around in just a little bit, and we'll go over everything together, and then we'll move forward. Okay? Any questions before we start? Allie?
I think you forgot.
I did the like denominators. I said those are the easier ones. That's the next page. There's like numerators, and then like denominators. And then this one. There should be 3 of them in there. 3 pages today. See them?
Okay.
Got them? Okay. Everybody should be on this page right here, comparing fractions with like numerators. Okay. So once again, we are talking about fractions with like numerators, right? So it just means that the part that you're taking away or that you're shading, the part you're representing, is the same, but it doesn't mean that the denominator, the size of the parts really in this case, are the same, right? So it could mean that you're looking at a numerator that looks like it's greater, but because the denominator looks greater, you might actually be looking at a smaller fraction, right? So let's look at a couple examples of that. Like this one actually, right here. 5/6 and 5/8, right? 5/8 looks like it would be greater, correct? Because it's got that 8 on the bottom, but remember what we talked about. If you're talking about a whole that's divided into 6 parts and a whole that's divided into 8, and we're making an assumption in this case that our wholes are about the same size, the 8s are going to be smaller, correct? Each one of those 8s, each one of those 1/8 parts will be smaller parts, won't they? Did any of you guys draw anything out to work on these, or did you just do it?
I just did it.
I figured.
It's really easy.
But see what I mean? See how each one of those 1/8 parts is smaller than these here? And also, I just drew 5 here, not 6, right? So, in that case, which is greater, 5/6 or 5/8? That's right. Okay, now, what about 1/6 and 1/2? Go ahead. 1/6 and 1/2, go ahead. 1/6 and 1/2?
1/2.
That's right. 3/6 and 3/4?
3/4.
That's right. And remember, guys, I know that I walked around, so it looked to me like everybody did have this page done, but again, I just want to reiterate that I want to make sure that everybody is using this time to make sure that you got them correct to participate, right? Because I have been giving you guys participation points on Dojo as a class, too. So keep that in mind. Go ahead, Nate. So, keep in mind, though, I don't want you guys just copying what I'm doing. I want you actually participating, okay? So,
If Heston said it's kindergarten stuff, why isn't he done? Yeah.
he is done. But also, that's not very nice, Sellers. We don't do that to each other. Okay. And it's not kindergarten stuff, because kindergarten don't really understand fractions like this. So, what it really means is that it's easy for you guys because you're good at it. This is 3rd grade stuff. And some of it is stuff we haven't really gotten to yet, which means you guys are a little ahead. So that's awesome. Okay, what about this one? 4/4 and 4/8.
4/4.
And 4/4 is equivalent to what?
1/2.
That's right. What about 2/3 and 2/5?
2/3.
Okay, we got it. What about 6/8 and 6/6?
6/6.
And that's equivalent to what?
1/2.
That's right. 1/3 and 1/5.
1/3.
Good. What about 1/4 and 1/8?
1/4.
Good. What about 3/5 and 3/8?
3/5.
Good. Okay, hold on. Now let's look at these bottom ones. 4/5 and 4/6.
4/5.
2/6 and 2/4.
2/4.
What is 2/4 equivalent to?
1/2.
That's right, 1/2. 2/8 and 2/3.
2/3.
Perfect. Now, honest. Was there anybody here who had anything different? You guys had a couple things that were different?
First one.
Okay, let's talk about it. So, Wilkins, what did you have in the first one?
No, it wasn't the first one. It was on the top right.
This one?
Yes.
So you thought 3/6 was greater? Now 3/6 is equivalent to what, guys?
1/2.
That's right. 3/6 is equivalent to 1/2, right? So if you were to draw this out, if you were to draw them out, let's do 2 holes right here. We'll do 1, and then we'll do 1 right here. In 4 parts, right? So if we were to do 3/6 straight down the middle, right? This line should actually line up right here. And 3/4, when in doubt, draw them out. When in doubt, draw them out. As you can tell on this one now that we drew it out, right? A little messy, but it works. You can tell that 3/4 goes a little further, right? It is bigger than 1/2. Think about it when you look at it as well. If I said to you, I'm going to give you 3 parts out of 4 total, isn't that better than just giving you half? It is, right? Yeah, does that make sense to everybody? Make sense? Thumbs up? Good. Jack, which one did you have different? A lot of them? So what part got you tripped up? A lot of them? Okay. Does it make sense when we go through and we talk about them? Did you draw any of them out? Like I said, when in doubt, draw them out. Draw it out. Draw out the shapes. Make it work, right? Like this one. You do it like this, right? Now these ones are a little harder to draw into equal parts. But if you were to draw it out, you would see 1/3 and 1/5. 1 out of 3 parts of that pizza would be bigger, right? Because the pizza is cut into 3 parts, which means each piece will be bigger. Whereas 5 parts, each piece will be smaller. Does that make sense? Kind of? For, what about this one here? Let's see. And again, sometimes I do it like that, just so I've got 2 holes on top of each other that look similar. Oh, I did that wrong. You guys got, whoa, we don't want to do that. No, yeah, we don't want to lose the whole thing, right? There we go. Looks like a little bit less confusing. We'll do it this way. These holes are the same size. It's got 4, and this one is going to have 8. Right? So they're not drawn perfectly, but you get the idea. 1/4 and 1/8. So really, ideally, you would be able to see that the 1/8 is half of the 1/4, right? Because we're cutting it down each time. Any of the other ones? Are any of the other ones kind of confusing? Any of those? Ali? I'm sorry, I can't hear anything you're saying. Yes, go ahead. Tell us.
That's this structure.
Yes, please do. Tell.
If you look at the 1/4 it looks the same, but on the
That's exactly right. And the further we would go in that direction, so let's say the next one we did was 1/16. That would be that 1/8 cut in half, and you just keep going in that direction. So it kind of looks opposite of what you would think because the numbers are going up. But when the numbers go up in your denominator, it means all your parts are smaller. That's why we use the pizza example, because if I cut a pizza into 4 pieces, right, like this, and then I cut a pizza into 8 pieces, which one has bigger pieces? That's it. 2 questions. Uh-huh. Well, that's right. That's right. Because sometimes, and that's why, remember when we did that problem last week where it was 2 families bought the same size bag of trail mix, but one family had 3 members, the other one had 4. So the family with 3 members had more trail mix apiece. It's the same thing. So if you have a family with 4 kids, each kid's going to get 1 piece. If you've got the same size pizza and you have a family with 8 kids, each kid's going to get 1 piece, but those pieces are going to be half the size, right? They're smaller. If you bought the same pizza and then cut it into 16 pieces because you're having a party, but for some reason you only bought 1 pizza because you're cheap and not very nice, just kidding. But that wouldn't be very nice, right? Because then you get 1/16. Your piece would be about, this big. Really skinny, right? Jack. What?
Over the map, I know the spelling technique now, so I can't do practice.
Good, I'm glad to hear that. But we're talking about math right now, guys. Let's keep going on the math. Okay, so let's move on to that. Do I have any more questions on this page, guys? Nick? Any questions? There's a spider behind me. On me?
On the bag.
On the bag. Which bag? Oh, you're right. How'd you see that? Well, I think we're going to let him go. I don't know if he's doing anything bad.
I just saw it.
What, you guys want me to kill it? Hey, guys, bring it back around. I don't need chance of kill it. Whoop. I think we lost it. Or is it still on here? Nope. So I think I lost it. I was going to bring it outside, but I think it fell. So it's somewhere over here. Just remind me if I try to put that jacket on or something. Okay. There's also a jumping spot. All right. Let's move on to the next page then. So everybody, turn the page to like denominators. Now remember, in this case, guys, there's a reason why I said these are easier. Like denominators are easier because you're talking about not only the same whole, but it's cut into the same number of parts, right? We're making the assumption, we're inferring. Remember what an inference is? We're inferring that we have the same size whole. Okay? We know it's cut into the same a number of pieces. We're just inferring that it's the same size whole here. That makes it easier to work with, right? Esther. Okay, Aiden. Yes, go ahead, quick. Okay. So in this case, again, we have the same number of parts that our whole is cut into, right? The numerators are different. Is 5/6 or 1/6 greater? Everybody? 5/6 or 1/6?
5/6.
That's right. Because in this case, guys, again, when in doubt, draw it out. Look. The holes are cut into the same number. 1 is only one of them. 5/6 is definitely greater. You're getting more parts, right? Talent, question. Yep. Okay, 6/8 or 5/8, guys.
6/8.
3/6 or 6/6.
3/6.
Ooh, let's go back to that, guys.
6/6.
Okay. What is 6/6 equivalent to?
1/2.
That's right. What is 3/6 equivalent to?
1/2.
That's right, 1/2. This is a whole and a half. Because remember, 3 is half of 6, so that's how you can tell. That's your hint. 4/8 and 4/8.
4/8.
4/8. What is 4/8 equivalent to?
1/2.
That's right. 2/3 and 1/3.
1/3.
Whoa. Back it up. 2/3 and 1/3.
2/3.
2/3. Guys, remember in this case, because the denominators are the same, if the numerator is greater, then that's the greater fraction. That's it. Briggs. Yes, please do. Schmidt.
I'm the ones that said 1/2 because I don't know what's going on. That I know.
Okay, good. What about 3/4 and 4/4?
4/4.
And 4/4 is equivalent to what?
1/2.
Good. 2/5 and 1/5.
2/5.
Good. 1/4 and 2/4.
2/4.
That's equivalent to what?
1/2.
That's right. 3/5 and 4/5.
4/5.
Let's see. Now we have 2/6 and 4/6.
4/6.
That's right. 3/8 and 2/8.
3/8.
Yes. 1/3 and 2/3.
2/3.
Good. Does anybody have any questions on those? Honest. Anybody have any different ones? Any confusion? No? Yes? Wilkins?
At the bottom middle.
Bottom one. You thought 2/8 was greater? Just remember. Put this in your memories. When you have the same denominator, if the numerator is greater, that's the greater fraction. That's only when you have the same denominator, though. The same numerator is different, right? But the same denominator, this one's going to be the greater one. Again, like I said, remember, when in doubt, draw it out. Right? Here's 2. And there's 3. Make sense? Jack.
I got it all right, but I erased it because I thought I got it wrong, but I got it all right.
Okay, good. I'm glad you got it all right. Now, the erasing thing, don't doubt yourself so much. Be confident. If you think that it's right, there's a chance that it is, right? Really, the truth is, even if it's not, you can always fix it. You learn from your mistakes, right? But don't doubt yourself, especially if you have it right. Abigail, go ahead and go. Great. Go ahead and go. Oh, I thought you were doing this. Yes.
On the board, word problem, changing individual.
What do you mean we do an individual? I'm gonna ask people for their answers. Absolutely. You can, but I thought you were going to the bathroom. Okay. Everybody go ahead and flip the page to the next one, to the word problems. Now, guys, these are word problems. I expect one complete sentence to answer them. Okay? You know what a complete sentence is. Remember caps, capitalization, accuracy, punctuation, and spelling. And I want you to also take one of our race components, right? Restate, answer, cite, and explain. I want you to use those components here too, especially the restating. You should always get in the habit of restating. And keep this in mind because we're starting that practice test for the state test on Wednesday. You got to remember that because you need to do that in the ELA section. That's one of the biggest things that people who grade these look for is restating. Restate. So always restate. You have to know how to use race. Restate, answer, cite, and explain. That is another reason why I have you guys do that with the math problems. Okay? Edit. Well, you can tell me the joke later. Okay? So remember that one with these as well. Restate, answer, cite, and explain. So, and again, this is something I want you guys to do whenever you have the chance to in writing. Underline, highlight, circle the important information. Okay? In this case, it says I ate 1/6 of a pizza. My brother ate 2/6 of the same pizza. And then the question, of course, is who ate the most pizza? Well, first of all, let's write down our fractions. Don't give me any answers. Tell me what the fractions are that we're comparing, Jack. Yep, so we're comparing 2/6 and 1/6. Now, it said this is the same pizza, so that's important, right? So you can also draw it out if you need to. But first, let's start by looking at which is greater. Who ate the most pizza? Chris?
The brother who ate 2/6 of it.
That's right. So what's a sentence that we could say here?
The brother who ate 2/6.
And what's the rest? Is who ate the most? You could say that. You could say that. That works. Or you could say the one who ate the most is the brother who ate 2/6 of the pizza. You don't need exactly what I have here, but you need a complete sentence. You could have said exactly what Rick said, or you could have said something else very similar. Tell him.
The brother who ate the most pizza because 2 slices is bigger than 1/6.
Good. And you see what he did there, guys? He explained. That's part of the restate, answer, cite, and explain. He explained that 2/6 is greater than 1/6. So that's very good. Andrew. Oh, you're so right. Okay, class. We'll finish going over this one right when you guys come back from recess. Okay, go ahead and go to recess, every house.
Don't worry, we're not late. The other kids just got out.
Aiden, go ahead.
I told you the joke now.
Okay, go ahead.
I will manage to substitute milk, chocolate, and butter. How dare you?
How dare he? Oh, that's like a dad joke. Okay, so this is the one. We need to finish going over the last few problems. Thank you very much. Go ahead and clear that out. And then we will move on. Okay, is everybody on this page? Yeah, thumbs up? Good. All right, let's go over the last few ones we have here. Sharon read 1/3 of her book, and Alex read 1/4 of the same book. So we have 1/3, 1/4 of the same book. Who read most of the book? So first question, what are the fractions that we're comparing, Allie?
1/3 and 1/4.
1/3 and 1/4. Now Schmidt, which one is greater?
Okay. 1/3 is greater, and Sharon read the most. Wait, Sharon read most of the book.
Good. Now I would add to that. I would add to that sentence because I want you guys to also cite your evidence. So I would add something to that, Sheba.
Sharon read more of the book than Alex.
You guys both have really good starts here. That's right, Sharon. read more of the book. You guys both wrote good sentences than Alex. But I want you to go on because, what else could I say there? Talon?
Because, well, can I read your mind?
Yeah, go ahead.
Sharon read more books because 1/3 is better than 1/4.
Good, good. And I'm going to say, very good. He gave his example. He cited his evidence. I'm going to say, instead of saying better, I'm going to say greater. Because that's a math word, right? Because 1/3 is greater than 1/4. You guys are awesome. Good. This is perfect. Ian.
The spider is still there.
Oh, did it come back?
Yep.
Oh, there it is. It's going right back to the back. Okay, we'll deal with that later. Come on, guys. Don't look at the slide. Sellers, sit down. Focus. Okay, so good job on that one, guys. Wrong direction. We've got two more. Mike ate 3/6 of the cookie cake. Meg ate 1/2 of the same cookie cake. Who ate the most of the cake? First, what are the fractions that we're comparing, Wilkins?
1/2 and 3/6.
That's right, 1/2 and 3/6. Now, some of you may have noticed this right away. Ariana, what is 3/6 equivalent to? That's right. So it looks to me like what we're really doing is comparing 1/2 to 1/2. So Ariana? Yes, that's good. Very good. And you cited your evidence. This is what I want to say, guys. Again, caps, but also race. Restate, answer, cite, and explain. You're answering all parts of it, and you're explaining why your answer is correct. That is extremely important. So the most important things you're going to do, again, on the state test is explain why your answer is correct. Andrew, go ahead. Schmidt.
Two things. I fixed mine, and before Talon said it, I put Sharon read most of the book because 1/3 is greater than 1/4.
Good, very good. Ian.
And then how do you spell equivalent?
I want you to figure that out. We've used it before. Try it before you ask me. We've used it. Ian.
Anyway, so yeah.
Hanson, go ahead.
My sentence is no one because the amount is the same.
No one because the amount is the same. So no one ate more cake. You could say that. No one ate more cake, so Meg didn't eat more cake than Mike, and Mike didn't eat more cake than Meg, right? Because they ate the same amount. That's right, they ate the same amount. Alec.
I wrote they ate the same amount of cake.
Good. But tell me why. You say because 3/6 is equivalent to 1/2, right? That's what I would add. So
I wrote they both ate an equal amount of cake.
they did. They did. And the only thing I would add to that, that's a good sentence. You guys all have really awesome sentences, really good sentences. The only thing I would add to those is make sure you're citing your evidence. So you're saying they both ate an equal amount of cake because 3/6 is equivalent to 1/2. And they both ate half the cake, right? Kind of a lot of cake. Alec.
I have no more room to write.
You have no more room to write, that's okay. Seva. Good. Tell it. Good. Okay, let's look at this one. Amelia ran 2/3 of a mile. Parker ran 2/4 of a mile. Who ran farther? Now, what are the fractions that we're comparing first, Briggs?
2/3 and 2/4 and 2/3.
Yeah, but hold on. What is 2/4 equivalent to, guys?
1/2.
That's right. So really we're comparing 2/3 to 1/2, right? So Briggs, what's your sentence? That's right. That's perfect. And he gave us the because at the end. He restated. He also gave us the answer and cited his evidence. You guys know what I mean by citing your evidence? You're telling me why you know that's true. Ariana. Good. That works too. Perfect. You guys see how you could write this in multiple different ways? Aiden. Go ahead. This is the water thing, remember? Oh, you can't see the. I'm going to move you up. Schmidt.
Okay, what I put is Amelia ran farther than Parker because 2/3 of a mile is greater than 2/4 of a mile.
Because 2/3 is greater than 2/4. Good. You could also say 2/3 is greater than 1/2. Perfect. Yep. Good. Go ahead. Wilkins.
I put Parker ran less than Amelia because 2/4 is 1/2 and 2/3 is less.
Perfect. That's good. 2/3 is not less so than 1/2. Greater. So almost perfect is what I should have said. 2/3 is the greater fraction. When in doubt, draw them out. When in doubt, draw it out. In this case, let's use a number line. Let's compare number lines. They're going the same distance, right? 0 to 1 whole. 0 to 1 whole. Now, this is where our half is on the first one. And we know that Parker ran half of the mile. Right here. I'm going to say Parker stopped here. Now, if we divide this one into thirds, Amelia is right here. Amelia ran further. Ran 2/3. When in doubt, draw it out. And remember, the reason I used a number line here is because number lines are good for showing distance, right? And since we're talking about distance here, it makes more sense than drawing out a pizza. Go ahead. Make sense, guys? Does that make sense? When in doubt, draw it out. Draw them out if you have to, guys. Draw them out. You don't have to rush through them. Draw them out. Take your time. Tell them.
Or you can draw a road.
You could draw a road. That's true. And that's basically the same thing we did. We just drew it as a math tool, right? Abigail. Go ahead. Jack, go ahead. Andrew. Okay. So, hey, patience, sir. Patience. Now, any other questions on the math before we move on? You guys feel pretty good about this today? Thumbs up. Again, you guys, be honest. If we need more work on it, we'll see that. We're gonna see it in a few days when we take the test too. So, we'll keep going, okay? Thumbs up though if you feel pretty good. Side with thumb if you're getting there. Down thumb if you don't get it at all. Yeah, we're getting there. Getting there. Yeah, that's good. That's honest. That's fair. And remember, guys, I said this last week. Good. You can do it, but you're kind of on the edge there. So, I really do want to say this again to you guys. I want you to be honest with me because it's the best way for you to learn. Okay. So if you don't get it, that's okay. Don't be embarrassed by that. Just tell me so we can work on it. Okay. I don't want you guys to tell me what you think I want to hear. I want to actually see it. I'd rather not hear it. I want to see it. If that makes sense. Okay. Say a question. Okay, good. She kind of gets it and she likes it. Go ahead and throw that away. Andrew. Good. Okay. Okay, guys, let's move on. Now we're going to go ahead and move on to our story.